Hello friends, welcome to our channel Red's Info Hub. I am Mr. Reddeppa Tanneeru. Yes, in this session we will discuss some examples of finding magnetic field due to finite, infinite and semi-infinite current carrying conductors. Let us start. Are you ready? Yes, take a pen and paper and let us start. Pen means paper means don't take a single paper, take a notebook and pen and try to practice along with me. Yes, first example is find the magnetic field B at a point P shown in figure. The figure is, we have a semi-infinite current carrying conductor. This is a semi-infinite current carrying conductor, and let us consider this is the horizontal line, and in this conductor a current I is flowing. With this horizontal line it is making an angle of 45 degrees, let us say, and let us draw one more dotted line to represent the vertical, and from this conductor along the vertical at a point P which is at a distance A, you are asked to find the magnetic field. Find magnetic field at a point P. This is our point P where you have to find the magnetic field which is at a distance A, right, as shown in figure. To find this, how to do? First, you know that to find magnetic field due to any straight current carrying conductor is B is equal to mu naught I by 4 pi D into sine alpha plus sine beta, right? But for semi-infinite conductor we have got separate expression, I mean an individual expression. Here we need to know what is alpha, what is beta and what is D, perpendicular distance of the point from the current carrying conductor. Then by substituting those things you will get the final answer. Let us see what is alpha and what is beta. For finding alpha and beta, just if you again compare, if this is a straight current carrying conductor, at this point if you want the magnetic field, from this edge you have to draw one line, from this edge we have to draw one line, from perpendicular conductor, from perpendicular line angle between this and this will be your alpha in clockwise, and in anti-clockwise one will give you, what is that, beta, and this is your perpendicular distance. If you compare here, you have to draw a perpendicular distance from conductor to the point. This is the point. If you draw a line, is this perpendicular distance? Or if you draw a line like this, is it perpendicular? No. So to understand that, let us extend the axis of the conductor, right? And now from this axis if you draw a line, we will get a perpendicular line from the conductor. This is perpendicular. Now this is perpendicular, right? If this is a perpendicular, then if you turn like this will also be a perpendicular. Now as this is perpendicular, we want this distance D, as it is A, and if you know this angle then you can get this D. By symmetry, as this is horizontal and vertical, the angle, this angle is 90 and this angle will be such that total of this angle should be 180. So 90 plus 45 plus this, if you say it is 180, this will, you will get this as this also as 45. Obviously this line is perpendicular to this, so this is 90 by symmetry, and this also will be 45 degrees. So the line drawn from this edge of the conductor to this point is making an angle of 45 with the perpendicular line. So D, over here D is equal to, as A is making an angle of 45 with this perpendicular line, D is equal to A cos 45. Is it clear? Carefully try to understand this. Is equal to, cos 45 is 1 by root 2, so it is equal to A by root 2. What is D? It is equal to A by root 2. Is it clear? Next, alpha and beta. And we know that whenever you draw a line from the point to the perpendicular line from point to the conductor, we have to measure the angles with respect to that perpendicular line. With respect to this perpendicular line, angle between this to the top edge is alpha. As it is going to infinity, already we know that in such case, as the alpha will increases gradually, and if it goes to infinity you will get 90 degrees or pi by 2 radians. Alpha and beta is the angle between the perpendicular line to right, perpendicular line to the line drawn from the other end in anti-clockwise direction. This bottom end, line drawn from this bottom end to point is this angle between perpendicular line and this, by taking in anti-clockwise direction. You shouldn't take like in clockwise, in anti-clockwise direction. This you have to be carefully keep in mind. Okay, so angle between perpendicular line and the line joining from the other end or bottom end in this case to the point in anti-clockwise direction is this. As if you take from here to here, this will be 360. So this angle 360 minus 45, this will be 360 minus 45. It will be some 315, but take as it is 360 minus 45 only. It is you will get you can see, you can understand the simplification if you take as it is in easy way. So let us take this as 360 minus 45 degrees. Now if you substitute these values over here, you will get the final answer. Yes, let me substitute and give you the answer. So B is equal to mu naught I by 4 pi into what is D? A by root 2. A by root 2 into sin alpha. Alpha is 90. So sin 90 plus beta is sin beta is 360 minus 45. So what you will get here? Sin 90 is 1. Sin 360 minus 45 comes in fourth quadrant. Fourth quadrant sign is negative, so it will becomes minus sin 45. So further you can write this as, if you take this root 2 over here, or root 2 mu naught I by 4 pi a into sin 90 is 1. This sin 360 minus 45 is minus sin 45, or you can take sin 90 minus sin 45 also. At the end you can take the values. This will be sin 90 minus sin 45. I hope you have understood this, because sin 360 minus 45, 360 plus 45 comes in first quadrant, minus comes in fourth quadrant. So it is in fourth quadrant, sign is negative. If you remember this, all silver tea cups in first quadrant, all are positive, all trigonometric ratios or angles. Here in the second quadrant, sine is positive. In third quadrant, tan is positive. In fourth quadrant, cos is positive. So in the fourth, 360 minus comes in fourth quadrant. So 360 minus 45 becomes so in this sign is negative. So sin 360 minus 45 is minus sin 45. So minus sin 45, right? Next, it is equal to root 2 into mu naught I by 4 pi a into sin 90 is 1 minus sin 45 is 1 by root 2. If you simplify further, you can write as is equal to root 2 mu naught I by 4 pi a into root 2 minus 1 by root 2. Root 2 minus 1 by root 2. So root 2 cancel. So you'll get root 2 minus 1 into mu naught I by 4 pi a is our magnetic field. Is it clear now? So therefore, the magnetic field due to this semi-infinite conductor at this point is B is equal to what? Root 2 minus 1 into mu naught I by 4 pi a. Yes, have a note of this. Yes guys, let us see the next question. The next question is, find magnetic field B at a point P which is at a distance A on the angular bisector as shown in figure. So this is the figure. In this, two semi-infinite wires have joined at this point, and the angle you can consider like two semi-infinite conductors are joined, or one infinite conductor is bent. Either way you can consider, so that the angle between these two conductors at this point is alpha. And on the angular bisector, that means if you draw a line which divides the angle equally, so this angle will be alpha by 2. On this angular bisector at a distance A, if the point P lies at this point, what is the magnetic field due to this system of two semi-infinite current carrying conductors where current I is flowing as shown in figure. If you observe here, as current is flowing in this conductor to the left, and if you stretch the thumb in the direction of current, and at the point P, due to this conductor, magnetic field will be into the plane. Similarly, due to this also, if you observe the if you stretch the thumb in the direction of current and stretch the fingers onto the point, the palm direction will be into the plane. So magnetic field due to both the conductors is into the plane, so they will add up. If you, and as they are symmetrically similar kind of conductors, if you find the magnetic field due to the one conductor, total field at this point is equal to twice the magnetic field due to one single conductor. So to find the magnetic field, what we have to do is, at a point due to straight current carrying conductor, from this point let us try to draw a perpendicular line onto the conductor, and as it is going to infinity, the angle made by the line joining from infinity into the point will make an angle of 90. So this it looks like a parallel line, so this angle will be 90. If you take it as alpha, it is equal to 90 degrees. Are you getting? And if you take this as beta, from the perpendicular line clockwise and from perpendicular line anti-clockwise, you have to measure the angles. And this actually, if you take by looking like this, if you consider that is top end, usually we consider the top end line joining from top end to this point, angle made by that line, we treat it as alpha, and this we treat it as beta. So beta is 90, alpha is what? You have to verify from this. As this is 90 and this is alpha by 2, this angle will be alpha is equal to, as this is alpha by 2, this you can take it as 90 minus alpha by 2. I hope you have understand this. So sum of these three angles will be equal to 180. Now to find the magnetic field due to this conductor, which is B, in general the general formula for B is mu naught I by 4 pi d into sine alpha plus sine beta. Here what is alpha, what is beta, what is d? If you know, then you can find B due to this conductor. Here what is alpha? Alpha is clockwise angle from this perpendicular line to this line, that is 90 minus alpha by 2. Alpha is 90 minus alpha by 2. What is beta? This is beta, it is equal to 90 degrees. I hope you guys are following right. Next, what is D? This is the perpendicular distance of the point from the conductor. This is D. So how to find this D? It is given in the question that the distance between the point and this point of intersection of this, that is that angular bisector point, is A. So in terms of A, you can find D as if you observe any of this angle or this angle, because this should include these two sides. If you take this angle 90 minus alpha by 2, you can if you take what you call adjacent side by hypotenuse, will give you this. Or if you take this alpha by 2, for this triangle it is opposite side, this is hypotenuse. So opposite side by hypotenuse related trigonometric angle you have to consider. So sine of this, if you consider sine of alpha by 2 is equal to opposite side by hypotenuse, it is d by a. From this you can consider d is equal to a sine alpha by 2. Or if you resolve this a, as it is making an angle alpha by 2, it is a cos alpha by 2 is a sin alpha by 2. D is a sin alpha by 2. Is it clear how to get this D? Now D is equal to a sin alpha by 2. You got alpha, beta and D. Let us substitute in this expression B. So B is equal to mu naught I by 4 pi D. Oh sorry, where D is what? D is a sin alpha by 2, a sin alpha by 2 into sine of alpha is 90 minus alpha by 2, 90 minus alpha by 2, and plus beta is 90, so it is sine 90. Did you understand? Right? Now further you can write this as it is equal to mu naught I by 4 pi a into sine alpha by 2 into, let us write sine 90 value as 1, so it is 1 plus sine 90 minus alpha, right? So 90 minus alpha falls in first quadrant, and 90 minus or plus will changes the trigonometric ratio. Sine 90 minus or plus gives a cos of that angle, so it is cos alpha by 2. So this is the value of this. This gives the magnetic field due to one infinite semiconductor at this point, and this also produces the same amount of field here. So therefore the total field B total is equal to 2 times this B is equal to 2 mu naught I by 4 pi a into sine alpha by 2 into 1 plus cos alpha by 2 is your answer. Or you can simplify further depending on the options. If the options, it is simplified as 2 into 2 times. If it is cancelled, you can write it as mu naught I by 2 pi a sin alpha by 2 into this. So depending on the options, you have to simplify further. Even if it is even further simplified in the options by taking this as like 1 plus cos 2 theta and this is sin 2 theta form, you can further simplify by taking 1 plus cos 2 theta is equal to, I can write it as 2 cos square theta, and sin 2 theta, if you take it as what, 2 sin theta cos theta form. In place of 2 theta we have alpha by 2, here alpha by 2. So if you further simplify this, what you will get, it is 1 plus cos alpha by 2. 2 theta plus we have alpha by 2. It is equal to 2 into cos square of half of this angle. Half of this angle is alpha by 4. Similarly, sin 2 theta plus we have alpha by 2. So you can write this as 2 sin alpha by 2 into cos alpha by 2. So ratio of this 2. So ratio of this 2, I am giving you directly. Ratio of this 2, if you equate this, gives you what? 2 cancel, 1 cos alpha cancel, cos alpha by 2 sin alpha, cos alpha by 4 upon, sorry, this is half of the angles, alpha by 4. Sin 2 theta is equal to 2 sin theta cos theta. 2 theta plus we have alpha by 2. So it is alpha by 4, alpha by 4. So we got cot alpha by 4. So this you can replace further as B total is equal to, let us cancel this also, mu naught I by 2 pi a into, what is that, cot alpha by 4. This also you can express by simplifying further. Depending on the options, you can leave it here or you can do simplify up to here, depending on the options. Is it clear, guys? Yes? Okay. Yes, guys, let us see the next question. The question is, a wire of length L equal to 2 pi r having current I is bent into n-sided regular polygon. You should know the meaning of regular polygon. It means all sides will be having same length. Regular polygon, and find the magnetic field B at its center. When you bend a wire of length 2 pi r into n-sided regular polygon, what is the magnetic field at its center? To understand that, let us consider a part of it, a part of regular polygon. A polygon, it can have, if it is having 5 sides, we call it as pentagon, 6 sides, hexagon, like that. So let us consider a part of it. So these 3 sides, and we know that the angle subtended at the center by the entire polygon will be 2 pi radians or 360 degrees. So that means the total length, I mean the total angle subtended at the center, if by n sides, if it is 2 pi radians, then the angle subtended by one side is 2 pi by n radian. Is that point clear? If angle subtended at the center by all n sides, if it is 2 pi radians, angle subtended by one side at the center will be 2 pi by n radian. So the angle subtended here is, this is the angle 2 pi by n radian. Is this clear? Next. And we know that the length of the wire is 2 pi r. This is bent into n-sided regular polygon. So length of all sides, that is n sides, length of all n sides is 2 pi r, whereas length of one side is 2 pi r by n. Length of one side is 2 pi r by n. Is these 2 points are clear? Now let us follow here. Is the length of this one side is 2 pi r by n. So it is 2 pi r by what? N is length of this complete side. And to find them, and we know that it is a regular polygon, all sides are identical. Regular means all sides are identical. So if you find the magnetic field due to one side at the center, then because it is having n number of sides, total field will be B total is equal to number of sides into field due to one side. We have to find first what is this field due to one side. Okay, now to find magnetic field due to one side, we know that B is equal to mu naught I by 4 pi d into sine alpha plus sine beta. Same here, what you have to get first, what is alpha, what is beta, what is d. From this, how to get alpha, beta and d? We have to draw a perpendicular line. At this point we have to find the magnetic field, right? So from this point, draw a perpendicular line onto the conductor. Let us call this distance as d, and angle made from this perpendicular line to this line and this line you need, and this total angle is 2 pi by n. Half of this will be pi by n, this also will be pi by n. Is it clear? 2 pi by n by 2 becomes pi by n. So both alpha and beta, alpha measured in clockwise, beta measured in anti-clockwise, both are pi by n and pi by n only. Is it clear? Next, D, perpendicular distance. The total length of this side is 2 pi r by n. Half of this by 2 means pi r by n is half of this. To find D, and as we know this angle is pi by n, let us take the side the trigonometric ratio which involves these two sides. So it is tan of this angle. If you take from the figure, tan of this angle, let us write here, tan, the angle is pi by n. Tan pi by n is equal to opposite side by what? Adjacent side, that is pi r by n by d. So we want d, take it here. So d is equal to pi r by n by tan pi by n. You can take it as cot what? Pi by n. So this is our d. So take d as what? I hope it is clear, right? Pi r by n into cot pi by n. Are these things clear? Now substitute and let us try to find b. B is equal to, therefore b is equal to mu naught I by 4 pi. D is what? Pi r by n into what? Cot pi by n. And you can directly take this into numerator also, 1 by cot pi by n. The next step we will do that. So it is cot pi by n into sin alpha plus sin beta. Sin alpha and sin beta both are same. What is this? Sin pi by n plus sin pi by n. Directly you can write it as, take one more step, sin pi by n plus sin pi by n. Sorry, sin pi by n. Right? 2 sin pi by n. Now we can write this as, this is equal to mu naught I by 4 pi into pi square r n, let us take to numerator, into n, 1 by cot pi by n, let us take it as tan pi by n. This is 2 sin pi by n. 2 let us cancel, this becomes 2. So final step of this field, due to only one single side, is what is here? Mu naught ni by 2 pi square r into tan pi by n into sin pi by n is the magnetic field at the center due to one side, due to one single side. Is it clear? But due to all sides, n number of sides into n. Is it clear? So you have to multiply with n. So therefore, where should I write? Here. Therefore, B total is equal to n times B. So, let me write at some point. So therefore, B total is equal to n times B is equal to mu naught n square I by 2 pi square r into tan pi by n into sin pi by n. So this is the expression for total field at the center due to this n-sided polygon. Is it clear? Yes guys, let us see the next question. The question is, find magnetic field B at the centroid P of an equilateral triangle as shown in figure. So here this is an equilateral triangle ABC. In this, a current I is flowing from A to B, then to C, then to A back, and this is how we can also say that it is entering somewhere here, and after coming back to here it may be leaving, no problem. But this is what is given here, and the side of the triangle, equilateral triangle, is given as A. So due to this, what is the magnetic field at the centroid? How to find centroid? Draw a line from any vertex, join a line from the vertex to the midpoint of opposite side, you get median, right? So where these medians intersect, that gives what? The centroid. So if you draw, you can extend, but here we want to just find this point, so no need of this extended line, no need of extended line. This is what is our centroid. This is our centroid P. Here we want to find the magnetic field. Is it clear how to get this point? Yes. Now to find magnetic field here, obviously I can say due to this entire triangle, equilateral triangle, we have to find the magnetic field due to this first side, the second side, third side. then you have to add them. But if you observe, the magnetic field at the center is into the plane, so it will be having some magnitude and the direction will be into the plane, and due to this also it is into the plane, and due to this also it is into the plane, so we can add them. If due to one side it is into the plane, if due to another side if it is out of the plane, you have to subtract. But here due to all the three sides are into the plane, the direction is same, we have to add them. Is it clear? Now if you find the magnetic field due to one side, then total field will be 3 times that field due to that single side. It gives you the total field. Is that clear? Because it is equilateral triangle. All three sides produces the same amount of field at the center. So to find the magnetic field due to one side, we can say by the side AC, magnetic field B is equal to mu naught I by 4 pi d into sine alpha plus sine beta is the generalized formula we have to use to find magnetic field. Here we should know what is alpha, what is beta, and what is d. By substituting this in the expression, we will get B. So let us try to find out what are these things, alpha, beta, and d. So as this is equilateral triangle, all sides are equal to 60, 60, 60. Sum of the angles will be equal to 180. So this is 60, 60, and this also is 60. But this median is bisecting the angle. It is also an angular bisector. This angle will be 30. Is it clear? This angle will be 30, and as this is a perpendicular line, this will be 90. So obviously again this forms AP, they can consider some point C is a right angle triangle. Some of these angles also equal to 180. As this is 30 and 90, this will be 60 degrees. Is it clear how to get that? Similarly, as this is 90, this is the total angle is 60, means this will be 30, and this is 90, so this also will be 60 degrees. Now as per our earlier discussion, if this is the right current carrying conductor, and if this is our point, the perpendicular line, this will be alpha, and this will be beta. Angles will be measured from perpendicular line. From perpendicular line, this is our alpha, this is our beta. Both are equal to 60. So 60 and 60. One is in a clockwise direction, another one is anti-clockwise direction. So both we are taking it as plus 60 plus 60. Then what is D? So D is the perpendicular distance from the current carrying conductor to this point. How to find this? As this is A, half of this point is midpoint of the side, this line. So this distance will be A by 2. Is it clear? And by knowing this, how can you express D? And by knowing these angles, as you can take this triangle by taking tan 30, which is equal to opposite side by adjacent side, or tan 60. For this it is opposite side and this is adjacent side. So if you take tan 60 or 30, any angle you can take, tan 60 is equal to opposite side is A by 2, by adjacent side is D. So from this D is what is tan 60? Root 3. So root 3 is equal to A by 2D. From this D is equal to A by 2 root 3. Did you understand how to get this? Did you understand how to get this? Yes. Yes. So D is A by 2 root 3. Let us take here A by 2 root 3. We got alpha, beta, and D. Now let us substitute here to find B. So B is equal to mu naught I by 4 pi D is A by 2 root 3 into sine alpha is 60. Sine 60 plus sine beta is also 60. So sine 60 is what? Yes, very good. Root 3 by 2. So this root 2 root 3, let us take to numerator. It becomes 2 root 3 into mu naught I upon 4 pi A to, it is 2 sine 60. Sine 60 is root 3 by 2. Sine 60, sine 60. Sine 60 plus sine 60 is 2 sine 60. So 2 into sine 60 is root 3 by 2. So 2 cancel. Here next step, this root 3 into root 3 becomes 3. 3 into 2, 6. So 6 mu naught I by 4 pi A is the magnetic field at the centroid due to one side of equilateral triangle. So the total magnetic field at the centroid is B total is equal to, because it is having 3 sides, so 3 times B is equal to 3 into 6 mu naught I, 6 mu naught I by 4 pi a. So if we simplify this further, we can say 2 2's 2 3's, so it is equal to 9 mu naught I by 2 pi a. It is total magnetic field at the centroid due to this equilateral triangle. Is it clear? So take a screenshot or pause and try to write down and go through. If at any point if you are not following at once, try to go through once again. Yes, I hope it is clear for you guys. Let us see the next question. The question is, find magnetic field B at a distance A from an infinite thick wire. Underline this word, thick wire. Thick wire at a distance A from an infinite thick wire. Infinite is also important. Infinite thick wire having uniform current I as shown in figure. So this is the conductor. It is an infinite conductor going up to infinity at the top, and bottom is going up to infinity, and its thickness is given in the figure as L. L is the thickness of the wire, and it is given that current I is flowing in this. You are asked to find magnetic field due to this infinite thick wire at a point P, which is at a distance A. Distance of this point from this conductor, that is means from this end, it is given as A. For finding the magnetic field due to this entire conductor, what you have to do is, let us divide this thick wire into identical smaller strips. Number of smaller strips, like smaller strips, like this. All right, and are you following? Let us divide this into such smaller strips, so that if you can find the magnetic field somewhere here due to one such smaller strip, then to find the total field you have to integrate, because these are identical strips. Let us consider one such smaller strip is this, right, and its thickness is dx. Let us consider its thickness is dx. Are you following? Let us consider one of the smaller strip of thickness dx at a distance x from this point. This is the distance of the element from the point P. And let us say the magnetic field due to this small strip is dB over here, right? And as the current is distributing uniformly throughout this thickness, the amount of current flowing through this smaller strip, let us say the amount of current flowing through this smaller strip, let us say is di. So total current in the entire thickness of the conductor is I in the entire thickness L. So to find the current through this smaller strip, you have to first find what is the current through unit thickness. In unit thickness, so you can say this in L thickness current is I. In unit thickness it is I by L. In dx thickness it is I by L into, in dx thickness current is di, it is equal to I by L into dx. Did you understand this? In the entire thickness L, current distributed is I. In unit thickness it is I by L. We call it as current per unit thickness. In dx thickness, in 1 unit thickness I by L, in 2 units into 2, 3 units into 3, in dx thickness into dx. So I by L into dx is the current flowing through this element of thickness dx, that is di. Did you understand now? Now due to this current element, what is the magnetic field? Let us consider this as dB. Let us try to find what is this dB. Then we can find the total field due to this entire conductor by adding those fields due to all such strips, that is by integrating. So the smaller amount of field dB here, yes, how to find this? Let us see. It is equal to, according to what you call Biot-Savart Law, mu naught I by already you can directly use the expression for magnetic field due to infinite conductor, or general formula if you write mu naught I by 4 pi what? Perpendicular distance d into sine alpha plus sine beta. General formula if you use, because it is an infinite conductor, for an infinite conductor, alpha is equal to what? 90 and beta is equal to 90, and perpendicular distance of this element, we are considering this element of thickness dx is x. Is it clear? Perpendicular distance of that element of thickness dx is x. If you substitute this over here, what you will get? dB is equal to, and what is the thickness of the element? We are trying to find the magnetic field. This is a dB due to a small element of thickness dx. In this, how much current is flowing? di. So here you have to be careful. This is not I, so this is di. So dB is equal to mu naught di by 4 pi. In general formula I have taken, so let us take here as it is I. Then you can write in this case dB is equal to mu naught di by 4 pi into our thickness is what? X into sine alpha is 90, sine alpha is 90, so 2 sine alpha is sine 90 plus sine 90 is 1 plus 1 is 2 into 2. Is it clear? So you can also express this as mu naught di by 2 pi x is a small amount of magnetic field produced here due to this smaller element. Now the total field B is equal to integral of dB. From where to where you have to integrate this element? It is equal to integral of what is this? Mu naught di, mu naught di, and again here di is equal to I by L into x. Di is here only, let us write, it is mu naught di, it is equal to mu naught into di is I by L, you can write it as mu naught by 2 pi x into di is I by L into dx. So mu naught I by 2 pi L, mu naught I by 2 pi L into 1 by x dx. Here x is varying. If the element is here, x will be this much, a only. If you are going inside, x increases up from here to here. The distance is L. At this point, the distance is a plus L. So we are integrating from here to here. So you have to take the limits of x as a to a plus L. You have to understand this as well. Now these are all constants. Mu naught I 2 pi L. By taking these out, mu naught I by 2 pi L into integral of 1 by x dx, limits from a to a plus L. But we know that integral of 1 by x is integral of 1 by x. Very good. Is log x. So it is equal to mu naught I by 2 pi L into log of x with limits a to a plus L. So upper limit minus lower limit gives you mu naught I by 2 pi L into log a plus L minus log a. It is in the form of log a minus b. You can write it as log a by b. Directly I am writing here. So it is log of a plus L by a. This is your total field, total magnetic field. I am writing here again. So therefore, total magnetic field at this point due to this thick infinite wire is given by mu naught I by 2 pi L, where L is the thickness, into log of a plus L by a. This is the total magnetic field produced here due to this thick infinite wire. Is it clear, guys? Yes, take a note of it. If you need or if you have any confusion, pause it and go through once again. If you need any further explanation or help, just drop a comment in the comment section. Yes, take care, guys.